So in the last video, we introduced the four properties of logarithms, and we proved the product property and the power property. What we're going to do in this video is learn how to expand logarithmic expressions by applying the rule. Okay, so let's take a look at the properties for a second. These are the four properties. When we're expanding, what we're doing is we're going from this form where there's one log, we call this condensed form, to this form where it's two logs, and that's expanded form. So just like when we simplified exponential expressions, when we expand logarithmic expressions, there are two things that we're looking for, two, not three. So the first thing is we only want one log for each variable. And the second thing is we don't want any exponents. Okay, and the best way to show you this is just through a bunch of examples. So let's just start going through these examples. So we'll start off really simple, and then we'll slowly get more and more complex until we reach like the most complex that you can possibly get. And just like every other video, I recommend that you pause the video after I present the example and you try and expand it yourself, and then you start the video again to see if you were correct. Okay, so first example, let's take and notice how I'm pronouncing everything. Okay, log base 6 of m times n times p. So again, this is log base 6 of MNP. Okay, so we want one log for each variable. So if we want one log for each variable, we can apply that first property, the product property, to pull this apart. And we know that when we pull the logs apart, multiplication turns into addition. So this becomes log base 6 of m plus log base 6 of n plus log base 6 of p. So now we have one log for each variable, the variables being m, n, and p. We have one log for each variable. Notice all of our logs are base 6. Check that off. We're also going to look for exponents, but we don't see any exponents here. So we're actually done. This is expanded form. Okay, so we have expanded this log completely. Notice we carry the base 6 all the way through. And then this side is condensed form. I also want to emphasize that when we talk about no exponents, common mistake for students is that they believe that this is an exponent. This is not an exponent. This is the argument. This is a base. Be careful about your handwriting. It should look like that. That 6 should be very close to the bottom of the log. Think about it at the bottom of the G. Okay, and this, even though it may look like it's an exponent of 6, it goes directly next to the log. It's on the same line. Okay, and it is not an exponent. This is an argument. The whole idea of logs is that you don't have exponents in them. Okay. Okay, so let's take another example. So in this one, we're going to do log of the cube root of m to the 4th times n. Okay. So the first thing that we want to do is we want to take, a lot of times when you're not really sure what to do in math, you look at what's the ugliest thing and you say, how can I make it less ugly? So the ugliest thing here is actually this radical, and this 3 means that it's the cube root. And we didn't really spend a lot of time on this. We will when we get to radical expressions. But when you see cube root, you can switch this to a power. This is the same thing as m to the 4th times n to the 1/3 power. Okay, and I'll put this as a side note, just that if you have we call this the xth root of a. This is the same thing as a to the 1/x power. And again, we'll talk about that a lot more with radicals, which comes up right after logs. Okay, so we have the xth root of a is equal to a to the 1/x. Okay, so this cube root, we're going to turn this into m to the 4th n, make sure it's in parentheses, to the 1/3 root. And now what we can do is we can distribute this 1/3. So it's kind of like simplifying the exponential expression before we do our expansion. So we're going to distribute this. Okay, and what we did is we got rid of the radical. Okay, and I'll write the next step before we do it. We're going to distribute 1/3 to get rid of the parentheses. This is the easiest way to do this. It's not the only way. And we'll talk about that in a second. Let's first do the distribution. So when we distribute, what this becomes is log m to the 4/3 and then n to the 1/3. Remember, you multiply. Okay. Okay, our next step here is to expand. And when we expand, we're really using the quotient property and or the product property. So here we don't see any division, so we're only using the product property. This becomes log of m to the 4/3 plus log of n to the 1/3. Now we have one step left because, well, there's only one log for each variable, right? There's a log for m and a log for n. We do have exponents, so we can get rid of those exponents by bringing them out to the front. Remember, that was the 4th property of logarithms. Okay, it's the power property. The 3rd property, sorry. We can bring the exponent out to the front, and we proved the power property in the last video. So this just becomes so we're going to move the exponents. this just becomes 4/3 log m plus 1/3 log n. And you can't see that, so I'm going to move the 1/3 down. The 1/3 log n, I'm just going to move it down here so that you can actually see it. Okay. One thing to notice, there is no base here. Keep in mind, that means that it's base 10. Okay. So here, all we really had to do was get rid of our radical to make it look a little simpler, distribute the exponent, then your last steps are always going to be to expand and then get rid of the exponent. Okay. The other way that you could have done this, and I will put this, I'm going to put this in purple here. Okay, your first step would still be to get rid of the radical. So you would still want to do your first, you would still want to do that m to the 4th n to the 1/3. Okay, that doesn't change. The difference is that what you could do is you could move the 1/3 out to the front first, but this is more complicated, and you'll see why. If we do that, that 1/3 applies to the whole log m to the 4th n. And what that means is that when we expand it, the 1/3 applies to both of them. So you would want to put this in parentheses. And then at this point, you can either bring the 4 and then distribute the 1/3, or distribute the 1/3 and then bring the 4 down. Okay, that's up to you. Let's just show it as you're bringing the 4 over, and then you're distributing the 1/3. So we get 4 log m plus log n, and then you distribute the 1/3. Okay, and the difference between these two methods is really, do you simplify this expression first and then expand, or do you expand and then simplify? And that's going to be completely up to you. Okay, so in this case, we got rid of an exponent. Then we expanded. Then we got rid of an exponent again. So notice that this is a little bit less efficient because you're doing the same step twice. That's why I show you the other way, and that's why I'm going to continue to show you the other method, where we do it this way, where we simplify the expression and then we expand, okay, as opposed to expanding and then simplifying the expression by distributing, okay? And you may choose to do it differently with different types of problems too. Let's do another one. Let's do log base 2 of m squared n over p. Okay, so again, this one is not that complicated. It's really 2 steps, Okay, this expression is completely simplified, meaning we already have one of each variable. Okay, so we can just go straight to the expansion here. And if we go straight to the expansion, this becomes log base 2 of m squared plus log base 2 of n, that's the product property. And then we have the quotient property, minus log base 2 of p. And notice we did this all in one step. We didn't first do the m squared n. Okay, we didn't do log base 2 of m squared n minus log base 2 of p and then add these. So we use the product and the quotient properties simultaneously. It's the most efficient way to do it. There's no reason to do it any other way. Something else to note, it would not be possible to move this 2 out to the front at this point, because if you move it out to the front, you would be saying that this 2, this exponent, applies to everything. It does not. It only applies to the m. So the only time that you can move an exponent out to the front from the beginning is when it applies to everything that you're taking the log of, like you see here with this 1/3. Okay. And then here, the only thing left is we do have an exponent that we need to get rid of. So we're going to bring it out to the front. So we expanded. And then we're getting rid of exponents. And when we do that, we're left with 2 log base 2 of m, and there are no exponents in any of these others, so it's log base 2 of n minus log base 2 of p. And you can see we have one log for each variable and no exponents. And just a note, if you had seen more than one log, like you had seen log base 2 of m and it occurred twice, all you would do is just add the coefficients. Okay? Okay, let's take another one. So we have log base 3 of m to the 4th n over p squared q. Okay, there's a really short way to do this, and I'll show you that in a second, but in order to show you why the short way works, I have to show you the long way, okay? So the long way really just gives 2 extra steps. So the 2 extra steps is that you use the product property and the quotient property separately, which remember I told you up here you don't have to do. You can do it simultaneously, but I want you to see how it works here, okay? Because we don't have just one thing in the denominator, we have 2 things in the denominator. So if we use the quotient property, then this gives us log base 3 of m to the 4th n minus log base 3 of p squared q. Okay. Then what we can do is we can use the product property to split up each of these because these are being multiplied. Okay. So here, the first thing, we don't need parentheses. We can just say log base 3 of m to the 4th plus log base 3 of n. But now we're subtracting this whole thing. So when we expand this, we need to put it into parentheses. The first part could have parentheses, but since it comes first, going left to right, it doesn't need parentheses. It makes no difference. So log base 3 of p squared plus log base 3 of q. So again, first we use the product property, the quotient property. And then we use the product property. And what we can do is we can distribute this minus sign. So what does that leave us with? Log base 3 of m to the 4th plus log base 3 of n minus log base 3 of p squared minus log base 3 of q. And that's actually always going to happen, okay? Where when it's in the denominator, it gets a negative in front of it, because when it's in the denominator, when we first do the expansion, we're always going to have these parentheses, and that negative is always going to be distributed. So we could save 2 steps by just skipping right to that, by saying, okay, it's in the denominator, so it's going to get a negative in front of the log, because at some point it needed to be distributed. So we can go straight again, I'll put this in purple. You can skip directly to that step. And if you look on apps or any other place, they're not going to do this, okay? They're not going to skip directly to this step. And when you don't, it's actually far less efficient. You may as well use the knowledge that you have, and you're allowed to do that. So we're skipping right to saying, okay, if it's in the denominator, it's a negative log. And then from here, all we have to do is bring the exponents over. So now it's a 2-step process. And that's the way most of these problems are. The only time that it's more than a 2-step process is when you don't have a simplified expression, simplified exponential expression to begin with. Meaning, this is not simplified, okay? Like in the, in example 2. So let's just make a note of what we said. If a variable is in the numerator, the log is positive. And if a variable is in the denominator, the log is negative. And that's going to save us a lot of time. Okay, let's take some more examples. So our next one, it doesn't get really all that more complex than our next one, but we'll do a few that look kind of more complicated, okay? So let's take a 5th one. Let's say that we have log. We'll just do it without, we'll do it with log base 7 of n cubed p squared q over m to the 4th r. So just to show you how quick this goes, this is just a 2-step process. You're going to expand first. So this expression is in simplest form. So it's 2 steps. You're going to expand first, and then you're going to get rid of exponents. So our expansion is the variables in the top get positive logs. So we have log base 7 n cubed plus log base 7 p squared plus log base 7 of q. Those were all in the numerator. Now we take care of the ones in the denominator. those are negative because they're in the denominator. So minus log base 7 of n to the 4th minus log base 7 of r. So we did that really, really quickly. So now the only thing that we have to do is move the exponents out to the front, which gives us 3 log base 7 of n plus 2 log base 7 of p plus log base 7 of q, no exponent, so nothing to bring over, minus 4 log base 7 of m, and then minus log base 7 of r. So we expanded, and then we got rid of exponents. Okay, let's do another one. So for this one, we'll add in one more complication. So first of all, let's use ln. Everything that we say about log is true about ln too, because ln is log, just with base e. So this time, let's do m squared r cubed over q squared n to the 4th. But the extra complication is that we're going to take this whole thing and square it. So we have two options here, and again, it kind of depends on whether you're more comfortable expanding or whether you're more comfortable simplifying exponential expressions. If you're more comfortable simplifying exponential expressions, then simplify this expression first. If you're more comfortable expanding, bring the 2 to the front, expand, and then distribute the 2. And I'll show that with the next example that we do. So here, let's simplify the expression first by just distributing the 2. So notice we're distributing the 2 first rather than last. This becomes ln m to the 4th r to the 6th over q to the 4th n to the 8th. Remember, we multiply exponents. Okay. And now we can just expand and get rid of exponents. So by expanding, the m to the 4th and the r to the 6th are positive because they're in the numerator. And the q to the 4th and the n to the 8th are negative because they're in the denominator. So we can do this in one step. Ln of m to the 4th plus ln of r to the 6th minus ln of q to the 4th minus ln n to the 8th. And this leaves us with 4 ln m plus 6 ln r minus 4 ln q minus 8 ln n. And we're done. Okay. Again, the other method would be, instead of distributing, you would make this 2 ln m squared r cubed over q squared n to the 4th. Then essentially you would have this, except your exponents would correspond to these, with a 2 on the outside. And then you distribute the 2 to the coefficients. And you come up with the same thing, but it's more steps, okay? Instead of it being just these 3 steps, it would be 4 steps, okay? Let's show you an example of 2 different methods in the next problem, just so that you see how it could be done using 2 different ways. And this is really going to be the last one that we work through. So this one, let's take log. We're going to put in parentheses. It will absolutely not get more complicated than this, and this is more complex than what you would see on a quiz. Okay, so, and I'm not just talking about a mini quiz, I mean a unit quiz, so be aware of that. So let's say that we take square root of m. I'm going to put a little tail on the end, just that you know that that's the only thing in the square root. N cubed p to the 5th over n times q squared over p squared. Okay, this is the most complicated it's going to get. So what we're going to do is we're going to simplify the exponential expression, which is this expression first, and then we'll expand. Okay, then we'll do it where we expand first and then simplify. So if we simplify first, what we want to do is we want to distribute this 2, okay? And you can do more than one thing at once. What we're going to do is we're going to change this radical to an exponent, okay? So this is going to become log m to the 1/2 n to the 3rd p to the 5th, and then this q becomes q to the 4th, and we're dividing it by n, and then that p becomes p squared. And notice that we were able to just take this q to the 4th, this q to the 4th over p squared, that came from here. Okay, so all we did here was we changed the radical to an exponent. And distribute the 2. Okay, now we're ready to expand. Oh, sorry, before we expand, we want to, we still have more than one n and more than one p. Okay, so when we do that, we could get rid of that, and we have log of m to the 1/2 n squared p cubed q to the 4th. Okay, that's because we can subtract the exponents here. 3 minus 1 is 2. 5 minus 2 is 3. That's where it came from. So here, we just combined vertically. And now we just expand. So here, this is completely the product property. Log of m to the 1/2 plus log n squared plus log p cubed plus log q to the 4th. Okay, and then we know that we can bring those exponents out to the front, which makes it 1/2 log m plus 2 log n plus 3 log p plus 4 log q. So even though the original problem looked so complicated, it's actually not that many steps to get it completely expanded. And we just move these exponents out to the front. So here we use the product property. So that's one way of doing it. Let's take the second method. Let's expand first and then simplify, just so that you see how it's done and you can choose. So the first step wouldn't really change here, okay? You always want to get rid of the radicals, okay? So our first step doesn't change. The big difference is that we're not going to distribute this 2, okay? So we can do this in 2 steps. We're going to expand this expression, and let's get rid of the radicals simultaneously, because that's a pretty simple thing to do. So we have log m to the 1/2 n cubed p to the 5th over n plus, and then we're multiplying by this. So we're going to take the log of this expression. Q squared over p squared. Okay. Now we can expand the first half using both the product and the quotient properties simultaneously. So the n, and the p up here are all positive logs, and then this is going to give us a negative log. And we'll leave this alone for right now, okay? We'll do one thing at a time. So we get log of m to the 1/2 plus log n cubed plus log p to the 5th minus log of n, and then plus log q squared over p squared. So we use the product property, and then we use the product and the quotient property to simplify this first one. So this here is equivalent to this whole thing here. Okay. Sorry about that. Okay, and this is a square. And this is a square. Sorry, sometimes it comes out on my paper, but it doesn't come out on screen, so. Okay, so now let's deal with this part. So this part, it goes in 2 steps, okay? So in our 2 steps, we bring this 2 out to the front first. And then we expand, okay? So now we have equals log m to the 1/2 plus log n cubed plus log p to the 5th minus log n plus 2. And now we're going to expand this second one. So we expand it as log of q squared minus, it's minus because that p is in the denominator, log of p. Okay, and then our next step here, we're almost there. We distribute the 2 to get rid of these parentheses here. And you always want to get rid of parentheses so that you can, at some point, Make sure that you have one of each log, and if you don't do that, then you'll have more than one of each log. So we get log m to the 1/2 plus log n cubed plus log p to the 5th minus log of n plus 2 log q squared plus 2 log p. And now all we have to do is bring all of those exponents out to the front. Okay, almost there. That gives us 1/2 log m plus 3 log n plus 5 log p minus log n plus this becomes 4 log q, you're multiplying, plus 2 log p. Okay, now we're not quite done yet because we don't have any exponents, but we do have more than one log. We have a 3 log n and we have a negative log n. And we have a 5 log p. And I'm sorry, this should be a -2. I forgot it's a minus. And a -2 log p. Okay, so what we're going to do is we're going to combine like terms here. And this is our last step. So we get 1/2 log m. Then plus 3 minus 1 is plus 2 log n. Plus 5 minus 2 is plus 3 log p. And then plus 4 log q. So we just combined like terms. So we combine the 3 log n and the negative log n, and we combine the 5 log p and the -2 log p. And now we're done. And notice the difference in steps. This is 1, 2, 3, 4. This is 1, 2, 3, 4, 5, 6. So it's the simplifying first and then expanding is always going to be more efficient. But again, if you're really uncomfortable with simplifying exponential expressions, but really comfortable with expanding logarithmic expressions, then you're going to use the second method. They're both perfectly valid. Okay, I'm going to give you one more example, but we're not going to work through this together. This is like huge challenge. You work on it on your own. It's not homework or anything. Just work on it on your own and see if you can get the correct answer. So I'm going to give you the correct answer here. Okay, so I'm warning you ahead of time. Spoiler alert, there's going to be the correct answer, but I want you to pause the video as soon as I write the example so that you can work on it by yourself. So the last one, the most challenging that you'll ever see it, you will not see anything more complex than this, would be log the 4th root I'm going to make this a little straighter. Of m to the 5th n cubed times the 6th root of p q r over p And this whole thing is squared times p squared over q to the negative 3 to the negative 3. Okay, so the fourth root of everything under here, m to the fifth n cubed, sixth root of p qr over p squared, and then times p squared over q to the negative 3 raised to the negative 3 power. Stop the video. Okay, now the answer to this, what you should be getting, is 5/2 log m plus 3/2 log n plus 1/2 log r minus 23 over 12 log p minus 7 over 4 log q. And if you got this as your answer, then you have mastered expanding logarithms. And that's it.